We want to look at some properties of limits.
Is this 4.5?
Properties of limits. We're going to let C and L be real numbers. Okay, well, it'd be infinity. Okay, I'm going to move this up and we'll work just a couple of examples. And then you can take, thank you. So y'all missed some of that. We're taking the limit as x approaches 0 of 1 plus 1 over x squared. And that's going to be 1 plus. Now what's the limit as x approaches 0 of 1 over x squared?
0. Oh, it does not exist.
It's what, Joey?
It does not exist.
And how is it, what's happening? Which way does it not exist? Describe to me what's happening.
Oh, it's unbounded.
Unbounded. How? To positive infinity or negative infinity?
To negative. Positive.
So this equals infinity, right?
Yeah.
Now, if we were going to look at that graph, 1 over x squared looks like this. If we add 1 to it, it just shifts everything up 1 unit. You need to know what this graph looks like, what 1 over x squared looks like. Joey, you need to know what 1 over x looks like. You could have questions that are non-calculator active on a test, and I would expect you to know what that graph looked like. Okay? Let's look at another function. The limit as x approaches 1 from the left of x squared plus 1 over the cotangent of pi x. Well, what's our limit on top?
3, 2.
It is what? 2. What about on bottom? Okay, now if we plug in a 1 here, what the cotangent of pi, that's where we would have a vertical asymptote.
0.
Okay, so at x equals 1, we have a asymptote. Now from the left, cotangent looks like this, remember. If this is pi, cotangent looks like this. So as you approach from the left, what's happening here? Negative infinity, and so this equals, the limit is 0. All right?
Why is it 2 over negative?
All right, because this is what the graph looks like when we've plugged in a negative 1. The cotangent of pi is 0, so at negative 1 we have at 1, this is actually 1. We have a vertical asymptote when x is 1. Because when we plug 1 into the cotangent for x, we get the cotangent of pi, which is 0. That means we have a vertical asymptote. And the cotangent graph looks like this. So notice it's headed to negative infinity. It's going to negative infinity. So we have a constant over infinity, so the limit as x approaches 1 is 0. Right, let's look at one more. The limit as x approaches 0 from the right of 3 times the cotangent of x. So as x approaches 0 from the right, what's the limit of the cotangent? As x approaches 0 from the right, what's the limit of the cotangent? What's happening to the cotangent? It's going to positive infinity, so this is really like 3 times infinity, which is just infinity. Right?